All right, welcome. I've got minimal announcements to go over with you guys. There's Mr. Oblhausen. All right. Let me just go over a couple announcements. I'm still playing catch up and we're having to do interims right now here. So if Mr. Melendez, I've already talked to Mr. Bigelow. Let's see, Mr. Oblhausen and Mr. Melendez, if you could just stay after class for just a second so I can kind of try to catch up on some things I'm missing from you two guys in particular.
Yeah, I'm getting all of it together so I can send it one time.
Oh, why don't you, because I got to do interims, and if I have it, you know, it would reflect much better if I at least have a little bit, but I would need them. I've got to do interims this evening, or I'm going to actually have them turned in today.
Okay.
But I may not make that deadline. So, sooner the better, and it can be piecemeal is okay too. Do not put them in Dropbox. Put them email them, because to go back through Dropboxes, I got to go through everybody's stuff to find out who's added to it from when I graded it, 2 days ago or 2 weeks ago.
Okay.
All right. Any other questions before I go over a couple other things? We're gonna wrap up 5-2 today. All right, using the problem set 3B from Monday. About 6 or 7 of you put it in Dropbox, which I got. If you put it in emails, I haven't been able to check emails, but I do have the 6 or 7 of you that put that in, and there's some common mistakes being made by you guys. So I'm going to kind of address those today in our examples. And then the last 15, 20 minutes of class, we're going to jump on to the next section. But before we do that, I'm going to put a 5-2 quiz, which will look like this 3D problem set, but instead of being like 16 problems, it's somewhere around 12 or 13, I believe. I'll put that in Blackbot probably tonight sometime, and you just need to do it by Friday. So it gives you 2 days to do it. Okay. And then we're going to jump to our next section. I'm cherry picking a little bit now, just because we can't move at the pace we were moving when we were in the classroom. And again, to get you guys prepped that are going to go on to pre-cal or calculus, we're going to jump to 6-4 next. And we're 6-4, 6-5, 6-6. All those 3 sections are related. It's kind of radicals type thing. So, and we've already done some of that. So it should not be a real brain buster. Stuff that SATs and ACTs like. All right, so that's kind of the announcements. Any questions before we get rolling? All right. So quickly, I'm going to try something a little bit different here. I'm going to share the screen for a minute, and I'm going to go to the Blackboard. But this is a problem set that we started on Monday. I'm a day straight here because everybody seems like the same. And so I'm going to put the answers up there, and I'm going to work a couple of problems for you. We're going to talk about these on the back side. Each one of these here, let's see if I can do this. 10 through 14, we had to use long division. Why? Because each one of these first half of the binomial or divisor has a coefficient other than 1, and this one threw you a curveball. Looking at going over some of the problem sets you guys loaded in Dropbox just a little bit ago. This guy has an h squared. So our first component on that's going to be 4th over h squared is h squared. So this is a little trick to it with that h squared. I'm going to talk about that. All right, let's see. Turn that off. And if you've got your problem set there in front of you, I'm going to show you the answers for for the first 5 or so, it's 3579. Let me turn the light off. I think I knocked some of the glare out.
Sir, for
Yes.
number 2,
Okay.
why is it +8 if it's 3 plus 4?
Number 2. Let me see. Oh, I don't know where did that come from? It's 2x plus 7, right? I don't even know where I got that from when I put it up there. Does that answer your question?
Yeah.
All right. Take a look at 3579 and take a look at 2468. I didn't put 1 up there because I know 1 we did in class, right? And then I want to talk about number 8. I want to walk back through number 8 because looking at some of your all's answers, several of you got that particular one incorrect. I'll take a minute. I'll just kind of stand out of the way. If you've got a question on any one of these except 8, because I'm going to walk you through that one, let me know. And we will. And then we'll get going and do a couple of long divisions on the back side. You may hear a bunch of pounding and drilling and stuff. They're cutting through the wall down right below us, making a new office there, down there back by some of the military offices. So there's a lot of construction. Anything on these 7 or 8 answers, not counting 8? Any confusion or that I can clear up?
Can you do number 5?
Yeah.
5. Yeah, let's see. Let me slide the cart down where I got some open board because I don't want to erase what I got. So let's see. We'll do it right below. Let's see, number 5. You want to do it long or synthetic?
Synthetic.
Synthetic. So I'm going to write the problem. We got 2x cubed plus 6x, and I probably can tell you where it may have broken down. Plus 152 divided by x plus 4. And here's probably where the breakdown occurred. Remember where we said the variables with the exponents have to go down in sequential order, and if they don't, you've got to put a placeholder in there to solve it. So to do that, the 2 comes down. There is no x squared. So I'm just going to put a 0 with it to the second power there just to remind me. I got 6, and then I got 152. Okay. And we're dividing by x plus 4, so we reverse the sign, it's -4. We draw a line with a space. The 2 comes down a little bit. The 2 comes down just as written, okay? -4 times 2 is -8. And remember with synthetic, we're always adding. So 0 plus -8 is a -8. -4 times -8 is a positive 32, right? We're adding again, 36 plus a 32 is now a 38. And -4 times, where are we? -4 times 38, I'm sorry, had a brain fart there, is a -152, okay? So we got a positive 152 and a -152 added together, that's 0, okay? Now, so that addressed, this -4, all we addressed was dividing by 4. We didn't address the dividing the x part of that binomial of x plus 4. So how do we do that? We just power then the initial element of that polynomial. So this becomes 2x squared. That becomes x, and that's just a constant, and we're done. That would have been our remainder had there been one. So I imagine probably, Mr. Dosh, where it broke down is because we went from x cubed to x, and so we have to, whether you're using long division or synthetic division, we have to put a placeholder in there to work the system either synthetically or long. Does that make sense?
Yep, thank you.
So similarly, there was some error, and I just picked this one out. This is, let me just make sure we can see what we're doing. Sorry, because I'm looking off a small little screen. Let me back up to get a little more room. All right. This is, let's see, this was number 8. All right. Number 8 had a big, number 8, actually that was similar to number 6 because we had a problem here. We got 3m to the 5th plus m minus 1 divided by m plus 1. Okay? So to do it synthetically, there's no m to the 4th, there's no m to the 3rd, there's no m squared. So I just put the 3 placeholders of 0 in there, just put the 4, 3, 2, all right? And negative 1 comes down as is. Oops. Yeah, oh, I'm sorry. The m comes down as 1, the negative 1 comes down as negative 1. So that's kind of the setup. Any questions before we run it through? All right. So 3 comes down as written. We got negative 1 times 3 is 3, right? 2 times 3 is a negative 3. We're adding, so 0 plus negative 3 is negative 3. Now we've got negative 1 times a negative 3 becomes a positive 3. 0 plus 3 is a positive 3. Now we've got negative 1 times 3. You can kind of see there's a pattern developing here. Negative 3. 0 plus a negative 3 is a negative 3. Negative 1 times negative 3 is a positive 3. 1 plus 3 is 4. All right. We still see, make sure I'm still on the screen, negative 1 times 4 is a negative 4. Excuse me. Negative 1 plus negative 4 is a negative 5. So that's quite a string of problems there. All right. So now what we have here is dividing this polynomial by 1. By this 1 here of this binomial. We haven't addressed the m. We addressed the division of the m by starting with 1 exponent less than what the original divider had was m to the 5th. So this becomes m to the 4th. This becomes m to the 3rd. This becomes m to the 2nd. This becomes m. That becomes the constant plus 4, and it's minus 5. That's our remainder because I've got my 1 constant here. You're not going to have 2 constants, so we're not going to add 4 to negative 5. It's negative 5 over m plus 1. I think that should match with my other answer over to the left. Let me just double check. It does. So if you can do one of those, if you got that one right on your sheet, then you've got this thing mastered. And the pitfall on all of these is to make sure you check and recognize if in what we're dividing into that every exponent is accounted for, and if it's not, in sequential descending order, and if not, we put a placeholder in there, and you're going to do that whether you use synthetic or long. Questions? And like, you know, I've said this over and over, the only way you're going to become, you don't need to become an expert, but you want to become proficient in there, in that you just got to sit there for 30 minutes and run 5 or 6 of them. But after that 30 minutes, you'll be pretty darn proficient to be able to do them well enough. You just, you know, work methodically to avoid making careless errors.
Mr. Gaffney?
Yes, sir.
I was going to ask, have you received my email with my work?
No.
Have you checked?
Yes. Okay. Let's flip it over. Is there any questions on side 1? All right, flip it over to side 2. Let's see here. Over here. Erase what we just did. All right. Let me see. Make sure. I want to make sure you can see this. All right. On the back side. Let's see. I don't have the answer for 10. 10 we did in class. I'll go ahead and put It's out of order, but I didn't put 10 up there. We did that in class the other day. So it's, the answer was 2x plus 2 plus 12 over 2x minus 3. So there, make sure you can see everything. I think you can. Just a hair. So there's the answer for 11, 13, 14, and 10. And I'm going to walk you through number 12. And that's why there's that box there, and and that about a third of the way down the page to remind you, and I tried to give you that warning on Monday, because of that polynomial divisor, the x component having a coefficient other than 1, your only option is to do long division. All right. So I set up number 12 here. All right. And if you look, we kind of have a similar situation, not quite as extreme as number 8, but you went from p to the 4th to p squared. There's no p cubed there, all right? There's no p cubed. So we have to put a placeholder in, just like we did with synthetic, and then run the process, all right? And we're going to work from left to right, and you want to start zeroing this out first, and this out second, and this out third, to get all the way down to the end, all right? And you're going to remember, vertically, we're going to put the same base and same exponent on top of each other. So if you've got those kind of basics of procedure basics down, then you'll be in fine shape. So the first thing, let me make sure you can see, the first thing we're going to focus in on is how many 2p's are in 4p to the 4th. Let me see if that's a little bit low. Come up a little bit. So we got, the first thing I'm going to focus on is to zero out that 4p to the 4th by dividing by 2p. So this is what we're actually looking at first. And this goes back to 5-1. That's why we did so many of those. All right. So 4 goes into 2 times. And p to the 4th over p, remember we're divided, so we subtract. So that's 2p cubed. Right. So if I multiply 2p times 2p to the 3rd, I'm back here to 4p to the 4th. Right. Make sense?
Yep.
Confusion? All right. 2p to the 3rd, we watching, is going to go right here. Because this is my placeholder for the 3rd power. Now we're going to multiply this first part of our answer times our divisor.
Can you say that again?
Say it again?
Yeah, can you say that again? I didn't hear you. It broke up.
All right. Let me turn my volume up too a little bit. I forgot where using the 2p to the 3rd I obtained because I want to start zeroing out each one of these working from left to right. So I'm focusing in on that 4p to the 4th divided by that 2p to find out what my kind of multiplier or first part of my answer is going to be. And this, we came to conclusions. 4 over 2 is 2, and p to the 4th over p is p cubed. All right, and we talked about in the last couple of classes, we've got to align vertically each base, identical base with each identical exponent. So the p cubed goes right here over my 3rd power kind of column if we think in terms of verticalness here. All right, so now we're going to go 2p to the 3rd times 2p. Well, we already know that's 4p to the 4th because we did that intentionally, right? And then we multiply 2p cubed minus 3, all right? So that becomes minus 6p to the 3rd. Good so far? Now we're going to subtract. Remember, in long division, we subtract the bottom row from the top. So 4p to the 4th minus 4p to the 4th zeroes out. And that was your goal and intention all along, all right? So now I've got 0 minus a negative 6p cubed. That becomes a positive 6p cubed. Okay? This negative 17p squared just comes down as written. All right? So I want to now zero out the 6p cubed. So I'm focusing on those. What is 6p? How many 2p's are in 6p cubed? Right? So 2 into 6 goes 3 times. P cubed over p equals p squared. Right? So I know my multiplier here is going to be 3p squared, and it's a positive. So I'm going to put 3p squared. And as you notice, we've talked about the p's the same base, p and p, same exponent, squared and squared. So that all lines up vertically. All right, so now we're going to multiply the divisor by this 3p squared. We already know that's 6p cubed because we did that intentionally. And 3p squared times -3 is a -9p squared. We good so far?
Yes, sir.
All right, so we're going to subtract this bottom row from the top, and that zeroes out, right? Just like that zeroed out. And so I got -17p squared minus a -9p squared. So that's
Why is it minus a -9p squared?
because it was 3p squared times the -3.
Okay.
That's where the negative sign came from. And since we're subtracting this bottom row from the top, it's really 9p. Or I'm adding 9p squared to 17p squared, which becomes what? A -8
P squared.
squared. All right. So now we're going to focus in on this to find out how many 2p's are in -8p squared. All right. So 2 goes in -8, so -4, and p squared over p is p. So it's a -4p. Right? So that goes right here. P and p to the first power. All right. All right, so we're going to bring down the 14p, and that's a positive. All right, and now we're going to multiply. We already know this first one. We know that's -8p squared. And -4p times -3 is a positive 12p. All right, 4 times -3 is, yeah. All right, so we subtract the bottom from the top. That zeroes out, which is what our whole goal was, and 14 minus 12 is 2p. And the -3 comes down.
Yeah.
All right, so how many 2p's are in 2p? Here's 1. So I put +1. 1 times 2p is 2p. 1, can we still see it? All right, yeah, I'm still there. 1 times -3 is -3. Come back just a little bit, down a little bit. We subtract the bottom from the top, zeros out, and there's my final answer. 2p cubed plus 3p squared minus 4p plus 1. Done. Does that make sense? And/or are there any questions?
Yeah, that makes sense.
It's just, you can see there's a lot going on here. There's a lot of opportunity to make a Carol's there. Just focus and concentrate and kind of methodically work through. All right. So I did 10 yesterday or Monday in class. I just showed you number 12. Is there anything else on that backside we need to talk about?
Mr. Gaffney, I have a question.
Number 14, you just had to divide that 2x squared minus 11x plus 15 divided by 2x minus 5.
What did y'all do Monday? Because I wasn't here Monday.
I'm sorry?
What did y'all do on Monday?
Oh, you just have to go to my YouTube link and watch the class on Monday.
So, is there anything I need to turn in?
If you watch the link and write me a 4 or 5 sentence paragraph of what we covered in class, I can give you partial credit for attending class, for getting the class.
Is that how it's always been, or that's new?
Yes, sir. Hasn't changed in weeks. Okay. So, is there anything on the backside else I need to clear up or go over? Anything on the backside? So everybody's good to go? You can take the quiz. The quiz will look like this. This had what, 13, 14 problems. The quiz will look like this, but probably have 12. As far as the, a problem like this or that number 8 I did over there, you're leaning towards, there'll only be probably 1 or 2 challenging like that, or it may be as a bonus. My caution to you is make sure you look at the exponents and they go down in sequential order and they're all accounted for. And if not, make sure you put the placeholder in. And like I said, it doesn't make any difference to me whether you use long or synthetic. Now, you will have to use long division if that binomial divisor has a coefficient other than 1. So you don't have a choice there. But any other time, I have no, I'm not going to force you to use one method or the other. They both accomplish the same thing. So watch out for that sequential. There's no lapses in that sequential decline. I mean, it's real obvious in some of those where it said like a to the 4th minus 16 divided by a minus 1. Well, it's pretty obvious there. We've skipped a whole bunch of exponents there. But in some of these others, like this here, number 12, we just did, you could easily overlook that there was no p to the 3rd power. So just be cognizant of that and look at that and make sure you account for that with a placeholder. Also, looking at the problems that you guys submitted, this problem set I looked at before class, make sure you've, let's go back here to the synthetic one. Make sure a lot of you guys were putting to the 5th, you were bringing the same powers down, 4th, 3rd, because the reason we dropped it down 1 exponent from the original polynomial divided into is this synthetic only addresses this dividing by 1. It did not address this until you reduce the power of whatever that first element is of that polynomial by one power. It starts off with m cubed or w cubed. Your first element and your answer should be m squared or w squared. So make sure make sure you incorporate that, because that addresses this half of the dividing process. That's kind of one of the little kinks to synthetic. All right. Questions as we wrap up this section? Everybody feel good about this section? You got it down well enough you can do pretty decent?
Yep.
Last call. All right, let's see what we got. We got time. Okay.
Stop by an after hours today and do some problems with you.
Sure. 2 to 2:30. And then 9 a.m. to 10 a.m. on Fridays. All right, let me see if I can do something again here. Hopefully it'll work. Let's see if it'll let me do that. Bear with me 1 second with little technical difficulties. Let's see if this will work for me. That was. Okay. Since I'm kind of filling in for Ms. Dolmage, I had to attend her class before the start of mine. I was trying to get this loaded up into Blackbaud before the class, but I wasn't able to. So I'll have this in Blackbaud. We got office hours till 2:30, so it may just give me till 3 o'clock to do that. Okay, but if you got some loose leaf paper there, you can take some great notes. Okay. All right, and I'm trying to get a pad that I can use to write with. There we go. All right, so this is the next section we're going to go into, and we're still going to be dealing with exponents, which you're going to, and talk with Ms. Dolmage. You guys are going to go on to pre-cal or calculus next year. This is some stuff that will help you transition into pre-cal for next year. So I'll load this up. The number one priority here the next day or two is to take that take the 5-2 quiz, and then this will be secondary. And if you could just do this by Sunday night, so I can take a look at how you're doing on this. for Monday's class. Let's see, yeah, Monday's class. I just want to have a feel for where you are, if it's coming easy to you or we need to slow down. Okay, so let me do something here. If you've got a pen and paper handy, you've seen some of these properties of radicals and roots before, but I'm going to kind of go over just to refresh our memory because it's fairly similar. We're going to go over each one of these properties because that's what you're actually going to use, and what it allows you to solve, and not really solve, but simplify these radicals and roots and exponential problems. So the first one is this square root property. It says, and it's a lot of verbiage, but I'm trying to boil it down to simple terms. It says for any real numbers a and b, if a squared equals b, all right? So let's just look at it. Let's just use, and pardon my handwriting here, this is not the most user. If I have 3 squared, but I'm going to change these variables to actual scenario because I think if you can relate it to the real thing. 3 squared equals what? It equals 9, right?
No.
All right. So that's what this first part of this problem has. So we're to here so far. Okay. Then it says then a is the square root of b. All right. So what that's saying, a in this case, our a is 3. So it's saying 3 equals, just pardon my writing, equals 9. That's what this property allows you to do, all right? So, square root is kind of the inverse of square, and square is kind of the inverse of square root. And that's what that property says for you to do. And here's another example. If 2 squared equals 4, then 2 equals the square root of 4. Okay. Good so far? So that's a good one. And I may try to add some of these before I put this in Blackboard for it. So I don't want you to focus too much on this other than take some notes, and we kind of tiptoe our way into this. Some of this should be somewhat familiar because we've done some stuff with roots and square roots and cube roots and that kind of stuff already. You still hopefully got that little 5x5, 4x4 little kind of cheat sheet of roots and typical roots and squares. All right, so the nth root, all right? So the nth root, that's like saying the nth root of this one is 2, right? So we're squaring. So for any numbers a and b, for any positive number, if an equals b, right? If an equals b, then a is the nth root of b. So let's relate it. Here's an example here. I'm gonna change things up just to give you another possibility. All right, so if I take 3, and this time I cubed it, all right? What does 3 cubed equal? That's 3 times 3 times 3. What's that equal?
27.
27. All right, so what that's saying, all right, so if 3 cubed equals 27, right? And I'm not going to write this out. Then another way of saying it is 3 is the cube root, or the third root. 3 is the cube root of 27, right? Or the cube root of 27, let me talk, that's not a very good 2, but it is a 2. All right, if there's no little number here under the radical, it's always talking square root. If it's something other than square root, it's going to have a little tiny number here. In this case, it's supposed to be a 3. We'll try to make it a 3. So the cube root of 27 is 3. Again, it's similar to that previous property. I'm just trying to give you a different take on it using cubes instead of squares. Questions so far? Some of this we did some of this back. I forgot what chapter, what section it was, but you've been exposed to this before, and I'm sure you did some of this in Algebra 1. All right, so let's talk about. This is where it kind of gets a little muddy. This real nth roots of b. All right, so I'm gonna kind of skip around here. Let me see let's skip around here. All right. So So let's look at this. If b is less than 0, b is what kind of number?
Negative.
Negative number. So let's use an example. So let's say we got negative 27. All right, if it's less than 0, it's got to be a negative number. All right, so there's my b less than 0. I'm just arbitrarily using this as an example. And if n is odd, n is going to be either our exponent or our root. All right, so if I'm doing this, I'm going to take the cube. So if n is odd, n is my little root here, right? So this is my root. That's supposed to be a 3. So I'm taking the cube root of negative 27. Now, let's put aside our discussions we had 5-6 weeks ago on imaginary and complex numbers. We're not going to get into that I stuff with this, all right? So this is an example with 7. So n is an odd number. So our root is an odd number, 3, 5, 7, 9, 11, right? And b is negative, which it is here. It says it has one negative real root, right? So does this have a plausible answer that's without using imaginary numbers? Does that have a plausible answer without using imaginary numbers? Anybody?
No,
Why not?
because wouldn't it have to be one of the threes would have to be negative?
Okay. All right. You're thinking in the right direction. But the answer to this is negative 3. It tells you right here, has one negative real root. Because negative 3, kind of going back the opposite direction like we did up here, negative 3, okay, to the third power equals what? Negative 3 times negative 3 is a positive 9. That's squared. But to the third power, that 9 is multiplied times negative 3, which now equals negative 27. So that is solvable, right? I can have a negative number under the radical and solve it as long as that root, right, or that n here, the n, is an odd number. Does that make sense? If you think about it logically, it makes sense. Does it make sense to you? Okay. Does silence mean no or silence mean yes?
Yes.
Yes.
Okay. So let's go back. We're kind of working backwards because I think it makes more sense too, but hopefully. All right. So it says if n is an even number. So let's say that means we're going to do something, a square root of something. That's n is 2. So if when it says n is even, it's going to be 2, 4, 6, 8, 10, 12, so on, right? If n is an even number and b is less than 0, and I think it was Mr. Cornett or somebody, means it's going to be a negative number, and I'm just going to arbitrarily use 4 just to change things up, right? Does that have a solvable answer without using imaginary complex numbers? There's a clue. The clue is no. It has no real roots because there's no number. Remember, there's no two numbers I can multiply and get a negative answer. Like negative 2 times negative 2. Or positive times positive. It's always going to be a positive number. So I cannot get the square root or any even root of a negative number under the radical. We kind of talked about this, but we kind of use smoke and mirrors, also known as imaginary numbers or complex numbers, back, I don't know, 8 weeks ago. So there is no answer. There is no plausible answer for this number 3 scenario. Does that make sense? All right. So we've done 3, we've done 4. All right. Let's see if I want to go, which way I want to go here. All right, let's keep working backwards. All right, so if n is an odd number, so I'm going to use to the third power or third root, okay, cube root, okay. And b has, let's see, and b is greater than 0, so I'm going to use 8, so it's a positive number. Right? So the cube root of 8, does that have a plausible, actual, real answer? Cube root of 8. N is odd. That's my 3. That's my root. Cube root. As I did that. B is greater than 0, which means it's a positive number. B has 1 positive real root. It tells you, yeah, the cube root of 8 is 2. Right? We're good there. Make sense? Hopefully.
Yes.
All right. Now, last one. Come out here. Let's see here. So it says that n is even. All right. So there we go. N is even. So that's square root, 4th root, 6th root, 8th root. All right. I'm just going to draw a little dealio here. So we're just going to let's see here. What do we want to do? Let's just keep it a square root since we're familiar with that. All right. And b is greater than 0. I'm gonna use, so it's just meaning it's a positive number. I'm gonna use 16. Okay. Then b has 1 positive real root and one. Can't even read. B has 1 positive real root and 1 real negative root. Why? Because the square root of 16 could be what? Let me see if I can write out here. Yeah. It can be a positive 4, and it can be a negative 4. Okay. Right? Because positive 4 squared is 16. Negative 4 squared is 16. So I don't want you to get hung up in the verbiage. I just want you to kind of understand and accept the properties that are listed here, these 4 in this bottom box and then the 2 boxes above. So there's 6 there. That allows us to simplify exponential problems and radical or root problems. Okay. Any questions before we move on?
Nope.
All right. So let's see here. Give me a second. Clear all this garbage off of there. All right, give me 1 second to. Oops. Yeah. All right. So I'm going to use the examples because they're pretty decent. All right. So in this problem number 1, we are taking, there's no n written here. So if there's no n in this radical, it's always a square root, right? So we got a little handy dandy cheat sheet. So we're just going to, again, kind of thinking in terms, if you kind of segment what our methodology of solving these are, is we're going to kind of look at these kind of like terms, all right? So 49, we got a little cheat sheet there. We've probably seen it enough. We know 49. We know the square root of 49 becomes 7, right? If it comes out the radical of 7. 7 times 7 is 49. 7 squared is 49. The square root of 49 is 7. That's all that stuff that was in those tables above us, applying, kind of saying, it's kind of like the scarecrow in the Wizard of Oz, where he's going like pointing both directions. We're going both directions, right? So 7 squared is 49. Oops, didn't mean to do that. All right, so we got 7, and now we got z to the 8th. All right, so how do we address that? How do we bring that out from under the radical? Well, remember when we were, I think it was 5-1, all right? Is, what is, if we look at z to the 8th, I'm trying to think how to, another way we could would look at z to the 8th is what? You know, what could I square to get z to the 8th? Well, I could square z to the 4th times, sorry about this writing, but it's easier to do this than on the board, I think.
Yeah, it's lagging on my screen.
Right? So z to the 4th times z to the 4th equals z to the 8th, right? Because remember, we have identical bases. When we multiply, we add the exponents, right? So the square root of z to the 8th, so I got two of these, right? Itself times itself. This would come out from under the radical as z to the 4th. Does that make sense?
Yep.
All right, fair enough. All right, let's see here. Okay. Let's look at the other example. There's no questions. All right, so now I'm taking, all right, so now they got something here, so we know it's something out of the square root. They're taking the cube root, all right, and applying kind of that same thing of how we looked at the z to the 4th, or z to the 8th is z to the 4th times z to the 4th. You could do the same thing here. 2a minus 1 is kind of like 2a minus 1 squared, then to the 3rd power. Because remember, remember we kind of talked about our label as our exponents have exponents. Because this 2 times 3, when our exponents have exponents, we don't add them like we did in that previous example. We multiply them. So I've got 2a minus 1 squared, then to the 3rd power these two things are equivalent, right? So this, since we're doing the cube root, this then would come out from under the radical as 2a minus 1 squared. Well, it's actually written up there. I don't have to scribble this out. Okay, so that would be the answer. The other thing which I didn't really address is this, there was a negative outside the radical that we never even touched. So it just stays there and it's not really impacted by the radical and what you're doing underneath there. All right. So that's how we doing. Actually, we're actually out of time. So I'll put this in blackboard, but just I'm gonna real quickly. All right. So what's the square root of 81? That's all they're asking you here. What's that equal?
9.
9. Done. That's all you got to do here. All right. So now we're talking the cube root of 343. All right. So now we're getting into something a little more technical. Yeah. So this one this is solvable, right? Because we said we can solve negatives under the radical as long as this nth root is an odd number, which it is. So we don't have to use the smoke and mirrors imaginary numbers, and we're not even going to touch that in this section. But if you put the cube root of 343 in your calculator, you're actually going to get 7, and then there is a plausible answer of -7, because -7 times -7 is a positive 49, and -7 times 49 is a -343. And then you can go from there, okay? I'll load this on the Blackboard sometime tonight, as well as the 5-2 quiz. All right, do the quiz first. Do that by Friday evening so I can grade it over the weekend. And I'll spell that out on Blackboard. And then do this by Sunday evening so I can look at these before we're back in class together on Monday. I know I covered a lot. We hit two kind of topics not quite related to each other. So I know I threw a lot at you in a short period of time. If you want additional assistance, come see me between 2 and 2:30 in the afternoons, or at 9 to 10 on Friday mornings, or go to Khan Academy or that patrick.jmt and just type in whatever the problem set header says or what we're covering, and there's examples there that you can also use to rely on. All right, I know I ran a few minutes long. Any quick questions before we go? All right.
For some missing classwork assignments I have, because I'm having I have all my work in my notebook, but I am missing some classwork assignments for classes I missed. So could I come to Friday 10 to 10:30?
9 to 10 on Friday, 9 to 10.
Can I come 9 to 10 on Friday and talk classwork so I can get those grades in?
Yep.
All right.
All right. Anything else? Anybody?
And then will there be something like if you do miss a class, like could we get our rep grade up? Like if we write about the class, we can get our rep grade up?
You go to the YouTube site, and I've got them all labeled like today's. Once I get it loaded up, we'll say Deep Period Algebra 2, Wednesday, April 22nd. So it's real clear which the classes are clearly labeled.
That's how we get our rep grade up?
I'll give you, because to get your rep grade is 45 points for each class each week. So that's 9 points. And then you come to office hours, you pick up another 10 points.
So that's how we pick up our rep grades?
Yeah. You won't get a full 45 points unless you, for the write-up, because you weren't actually in class, but you can get close to it. And if your write-up's very impressive, I'll get you close to 45. But I want you in class so we can have this interaction and Q&A.
Okay.
All right? All right, let's see here. Okay, any other questions by anybody?
After class, can I show you? My computer can't take pictures, and I have the missing work that I need to turn in on paper. Can I show that?
Yeah,
to you?
I'm doing everything on paper too. That's a problem I have too. I have all my work like in paper.
Can you do it using your smartphone? Or
I have a
yeah,
smartphone right now.
I'm sorry?
I have a working smartphone right now.
You don't have a working smartphone?
No.
Because there's scan apps that you can put on and scan it and send it to me that way. Some other guys I think are just taking flat out pictures and then dropping it either in an email or dropping it in Dropbox is another option.
Yeah, but my computer right now is I can't take pictures with this computer.
All right, let me think here. Let's see what else. How else can we do that?
Can I possibly hold it up to the screen and you can confirm that I did it, or?
Yeah, can you do that? Check in with me office hours the next day or two?
Sure. Can I just stay in the office hour today?
I got to stop it because I got to record this part. I don't record office hours. So
All right.
check back.
Yeah.
Same link, but just give me a couple minutes to. I got to stop this, shoot it to YouTube, and then I'll come back up on office hours.
All right. Sounds good.
Okay.
Okay.
Anybody else? All right. We'll see you in a bit.
See you soon, sir.
Okay.